Howdy, friends. It's good to see you guys. Good to see you all. All righty. So far we've been able to kind of go through a little bit here, and we dealt with a few of our derivative rules. Today we're going to add a couple more. Okay, now, unlike the couple of rules we did last time, I'm not going to go through and prove all these. I'm hoping now you guys kind of got the hint that a lot of these are springing from somewhere. They're not just coming out of nowhere. They're all coming from somewhere. All right. So our two rules we're going to look at today. One is called the product rule. And the other one is called the quotient rule. So that's going to be kind of the gist of what we're looking at here. So we got the product rule and we got the quotient rule. So here's what they basically say. The product rule. If I have a function and it's multiplied, it's essentially that function is two other functions being multiplied by, oopsies, I'm botching that up, there we go, f of x times g of x. The derivative of this function is going to be the first function, f of x, times the derivative of the second function, plus the second function, g of x, times the derivative of the first function, f prime of x. The quotient rule is going to be very similar to it. That it's made up of two. And it's got a couple little things going on to it. There we go. All right, and this one is a little bit different. It's going to be the bottom function times the derivative of the top function plus, or minus, sorry, minus the top function times the derivative of the bottom function all over the bottom function squared. So they're not really too terribly bad. It's basically, can we deal with just a couple random different equations or just a couple extra formulas in general? So we're not going to be doing too much with it. At this point in time, I would probably encourage you probably want to start making a flashcard for each derivative rule, so that way we can go over them repeatedly, like literally 5 minutes a night, just kind of walk through them. Do you understand what it is you're being asked? So let's look at a couple derivatives we looked at yesterday and see how this kind of applies. So 3x squared plus 4. Now, yesterday we said we're going to take this and we had to multiply it all the way out. Had to be careful with our algebra. And again, you go back and watch 2.2, you'll see where we actually did this one. But how would this have worked for the product rule? Because you need to realize one of the things that comes up with derivatives or with calculus in general is we have a bunch of tools. And there's different ways to approach a problem. If you don't like the way one looks, you can just change it. For instance, 3x plus 4 squared. What if we change that to be 3x plus 4 times 3x plus 4? If we did that, now we have pretty much our product rule. Here's our f of x. And this right here would be our g of x. And if it works, we should end up getting the same thing. So let's take a look. For following our little formula here, the first thing we have is f of x. So that'd be 3x plus 4. Times the derivative of g of x. So here's g of x. The derivative of that is 3. Plus g of x times the derivative of f of x, which is also going to be 3. And again, if you're having trouble seeing it, let me see if I can't write this in a different color here for you. Really want this to be clear. So what this said was f of x, so our first function, times the derivative of the second function, plus the second function times the derivative of the first function. Can you see it a little bit better now? So, and when we clean this whole thing up here, I have 9x plus 12 plus 9x plus 12. And friends, all together, I believe that means that we have 18x plus 24. Again, I probably would not have done the power rule on this one, but it gives us an idea to see how we have these different rules and we get to figure out which one works best for us. And to each person is going to have their own. Let's try another idea, another problem that we had. And then again, this is just from yesterday. So hopefully we've got a little bit of understanding of the product rule. We're going to try it again here in a second. But yesterday we also had this problem. We had f of x equals 5 over x plus 7. And when we did this problem yesterday, we brought that x plus 7 up. And we made it a -1 exponent. So we could then go ahead and do our derivative. And then simplify it. -5 over x plus 7 squared. Okay, so that was doing it with a power rule. What if we tried this one now with a quotient rule? How would we do that? So up top, we'd make this one the f of x. And I'll go ahead and just go right doing it the first time with color, just so you guys can see it again a little bit better. The bottom one, that would be g of x. So if I were to go through I take our first function, or the bottom function, g of x, and I plug that in the first parenthesis. The derivative of the second function, the derivative of f of x, that's 0, minus the top function times the derivative of the bottom function. The derivative of x plus 7 is 1, all over the bottom function squared. And if you notice, it looks something kind of like this. X plus 7 times 0 is 0. So we're left with minus 5 all over x plus 7 squared. So we have this idea of a product rule, of a quotient rule, and we can use them as it helps us out a little bit. So that's going to be the first thing we're going to try to do. We're going to do a little bit with the product rule, a little bit with the quotient rule. Then we're going to see a couple more ways that this might come into play. Okay? So let me give you guys a couple problems to try here. Let's see what you guys can do with it here. So we've walked through one of each. Let's see if we can get just a little bit cleaner. What if I told you that f of x equals cosine x times the cube root of x plus 8. And how about for this one? Why don't you guys try this one as well? G of x. That would be sine of x. All over x squared minus 3x plus 5. All right, why don't you pause the video and see if you can go through and try these here. All righty, friends. So if I'm looking at this first one, I see cosine of x. And hopefully after last class, we realize we do not deal with radicals at all. Everything becomes a exponent, an exponent. So that'd be 1/3. Okay, so here, even though we have it, this is our first function. And this right here is our second function. Whoop. So we're going to go first times the derivative of the second plus second times the derivative of the first. So first, the derivative of cosine is negative sine. Times the derivative of the second. So the 1/3 goes down. And again, being very selective of what functions I use here for my power rule. And in a couple of days, we'll see why. What do I mean by that? My exponent's going to go down, and then I got to subtract 1 from it. So that make this a negative 2/3. So then I have x plus 8 to the 1/3, the second. Times the second times the derivative of the first. I just realized I made a mistake. Hopefully you guys all yelled at your screen really loud. Say, Williams, supposed to be the first times the derivative of the second. So let's fix that. Plus second times the derivative of the first. You don't have to clean it up anymore than that. I mean, you can. There's a way to factor out the x plus 8 if you really wanted to. No reason to. But there we got a great answer. All right, here we go. Second one. G prime of x. All right, and we're going to have the bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom squared. All right, so here's our top function. And we could have called that f of x. We wanted to call the bottom function g of x, or you can just call it bottom, doesn't matter. All right, so first up, we have the bottom function, g of x, times the derivative of the top function. So the derivative of sine is cosine. Minus the top function times the derivative of the bottom function. So the bottom function would be 2x minus 3 all over the bottom function squared. And again, we do not need to simplify these. There's no reason to. But no matter how ugly that function is, we can figure out the product rule of the quotient rule. We can figure out the derivative for it. So one other little thing, let's add to it here, just for the fun of it. Because here's what kind of came next in the grand scheme of things. People started realizing, well, we could probably do more with this. For instance, what if we were to look at it in terms of trig? For instance, take tangent. We don't know any derivatives for tangent, but we do know that tangent is the same thing as sine over cosine. So if I asked you to tell me what the derivative of tangent was, what I'm really asking you is to tell me what's the derivative of sine over cosine. And if I ask you to do that, all of a sudden, friends, you would look at it and say, okay, well, I got my top function. And I got my bottom function. And we could probably go through and determine the derivative. So we have the bottom times the derivative of the top minus the top times the derivative of the bottom all over bottom squared. So here we go. Bottom, that was cosine x. Times the derivative of the top. Derivative of sine is cosine again. Minus top. Times the derivative of the bottom. So that'd be a negative sine x. All over the bottom squared. Well, friends, if I clean this up just a little bit, I believe I get cosine squared x plus sine squared x all over cosine squared x. And being the amazing math people you are, you actually remember this one from pre-cal. Cosine squared plus sine squared is 1, which they tell me is the loneliest number. 2 is better than 1, because 1's the loneliest number. And then 1 over cosine, well, that's the same thing as secant. So 1 over cosine squared would be secant squared x. Well, friends, turns out every other trig function actually is nothing more than just a quotient rule. So we can actually add that to our list of stuff. We could say, all right, well, tangent let's just make that equal to secant squared x. And if we went through and we did cotangent, maybe, we'd find out that that is negative cosecant squared x. And again, we'd prove it the exact same way. Cotangent is the same thing as cosine over sine. And we could do the same thing for secant. Use a quotient rule. Secant is 1 over cosine. Turns out this one ends up becoming secant x tangent x. And then our last one would be cosecant, which is 1 over sine. And it turns out that one ends up being negative cosecant cotangent. But all 4 of those can be proved just by using a quotient rule. So, friends, we can do a little bit more now. Notice now, all of a sudden, we are up to 10 derivatives. We've actually have more than that. There's technically a constant power derivative. There's a sum derivative. There's addition derivative, but they all fall under the power rule, so I don't even bother putting them up there. Why don't you guys try this one? Let's make that a little lower. How about this? F of x equals tangent of x minus 3 cosecant of x. So this second chapter is really about building a toolbox so we can apply the stuff the rest of the year. All right, why don't you guys pause the video, see if you can solve that. All right, let's do this. So my first derivative, my derivative here, I'm looking for tangent. So tangent, I go over and I try to find where tangent is right here. That equals secant squared x. So in place of the tangent, I'm going to type in secant squared x. That was ugly too. That's better. And then we're going to add, I lied, we're going to subtract 3. And we're going to now go ahead and figure out what is the derivative of cosecant x. So I go find that over in my little formulas. And when I find it, I can write it in. That's times negative cosecant cotangent. And then from there, just clean up the dumb thing. So we have secant squared x plus negative times a negative, so plus 3 cosecant x cotangent x. All righty, friends, you got 2 more to try there. So go and pause the video, try them real quick, and then we will take a little look-see. Go for it. All right, so this right here, here's my f of x, otherwise known as the first function. Here's my top function, also known as f of x as well. And here's my second function, also known as g of x. And here's my bottom function, also known as g of x. So, derivative time. Put out all my parentheses here, so I will have a bunch. All right, first, so that's secant x. Times the derivative of the second, so 2x plus 5. Second, x squared plus 5x plus 6. Times the derivative of the first. So secant x tangent x. Run out of a little bit of room. That's tangent x right there. Secant x tangent x. All right, well, I'll tell you what, on this one, before I even begin to solve this one, this last one here, I'm going to rewrite that. I'm good with the cotangent of x, but I do not like that square root. Friends, I am an exponent guy. We're going to make that x plus 2 to the 1/2. So we're going to have the bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom squared. Okay, so friends, here we go. Let's plug them in. The bottom, that'd be the x plus 2 to the 1/2. I could have done the square root just as easy. It's whatever works for me. Bottom times the derivative of the top. So derivative of cotangent would be negative cosecant squared x. Minus top, so cotangent x. Times the derivative of the bottom. So that means, let's remember here, I got my 1/2. So I'm going to drop it in front and then take away 1 from it. And we just think to ourselves, thank you that I don't have to simplify this. Now, if this were a multiple choice portion of the test, yeah, you'd have to simplify this. But if it was the multiple choice portion of the test, it wouldn't. Your answers wouldn't be this ugly either. And then lastly, all over the bottom square. So all over x plus 2 squared. So if I hadn't already put that 1/2 there, I could have just put x plus 2 because 1/2 raised to the 2 is 1. Well, friends, there we go. All right, that takes care of some more derivatives for us. So we got our product rule now, our quotient rule, and the rest of our trig rules. So see you in the morning, and we'll do a little bit more with this.